Next we are going to see radical axis of two circles. The radical axis of two circles is defined by the locus of the point which moves so that the powers with respect to the two circles are equal. We know power of a point with respect to a circle, right? In the previous video we defined all those things. So radical axis is nothing but between the two circles is nothing but the locus of the point which moves so that the powers with respect to the two circles are equal. So the locus of that point, the power of that particular point with respect to the two circles are equal. That is, radical axis of two circles is the locus of your point which moves so that the length of the tangents drawn from it to each circle are equal. So we know power of a point and length of the tangents have a relationship, right? So we already defined. So that is nothing but the length of the tangent drawn from that particular point, right, for the two circle, right, are equal. Then the locus of that particular point is the radical axis. So it is a straight line which is perpendicular to the line joining the centers of the given two circles. The radical axis of two circles is bisects the common tangents of the given circles. So the radical axis does not exist for the concentric circle, right? So these are all the things related to radical axis. So C1 is the first circle with center C1, then second circle with center C2, P is the point, then the line is the locus of that point, such that we are drawing the tangents from that particular point. So the length of the tangents both are for the both circles, for the first circle and second circle is equal. Then the moving path of that point, that is called the locus of the point, is called the radical axis, right? This is common tangent for the two circle. So the length of the tangent is PA, PB, both are equal, right? PP dash is called the radical axis. Here PA is equal to PB, and C1, C2, the line joining the centers C1, C2 is perpendicular to PP dash, radical axis, right? That is also there. So equation of the radical axis: if x square plus y square plus 2gx plus 2fy plus c equal to 0, and x square plus y square plus 2g1x plus 2f1y plus c1 equal to 0 are two non-concentric circles, then the radical axis of the given two circle is x square plus y square plus 2gx plus 2fy plus c minus x square plus y square plus 2g1x plus 2f1y plus c1 equal to 0. First circle minus second circle equal to 0, right? So that is 2 into g minus g1x plus 2f minus f1y plus c minus c1 equal to 0. Because when you are subtracting these two circles, x square term, y square term get cancelled. X square minus x square, y square minus y square get cancelled. Then grouping x term, you will get 2 is common, take it outside, 2g minus g1x, and grouping the y term, 2 is common again, plus 2f minus f1y plus the constant term c minus c1 equal to 0. So both are equal. We'll see the proof. Given circles are x square plus y square plus 2gx plus 2fy plus c equal to 0. That is equation number 1. And the second circle, x square plus y square plus 2g1x plus 2f1y plus c1 equal to 0. Let p x1 y1 be any point on the radical axis of 1 and 2, right? We know the power of the point x1 y1 with respect to the circle x square plus y square plus 2gx plus 2fy plus c equal to 0 is x1 square plus y1 square plus 2gx1 plus 2fy1 plus c, right? So we know that the radical axis is the locus of the point which moves so that the power with respect to the circle 1 and 2 are equal. So power of p x1 y1 with respect to first circle, which is equal to power of the point p with respect to circle 2. So power of p with respect to circle 1. So replace x by x1, y by y1 in circle 1. You will get x1 square plus y1 square plus 2gx1 plus 2fy1 plus c. Right? That is the definition of the power of your point with respect to the circle 1. Similarly, replace x is equal to x1, y is equal to y1 in equation number 2. You will get the power of the point with respect to the circle 2. That is equal to x1 square plus y1 square plus 2g1 x1 plus 2f1 y1 plus c1 equal to 0. That is x1 square plus y1 square 2g x1 plus 2f y1 plus c, taking that right hand side terms to the left hand side, minus of x1 square plus y1 square plus 2g1 x1 plus 2f1 y1 plus c1 equal to 0. So multiplying with that minus, removing that bracket on the second term, second circle. So you will get x1 square plus y1 square plus 2g x1 plus 2f y1 plus c minus x1 square minus y1 square minus 2g1 x1 minus 2f1 y1 minus c1 equal to 0. So x1 square minus x1 square, y1 square minus y1 square get cancelled. So remaining term 2g x1 plus 2f y1 plus c minus 2g1 x1 plus 2f1 y1 minus c1 equal to 0. So grouping x1 term, so 2 into g minus g1 x1 and y1 term plus 2 into f minus f1 into y1 plus constant term c minus c1 equal to 0. Hence the locus of the point x1 y1 is, so replace x1 by x, then y1 by y. So you will get the equation 2g minus g1 x plus 2f minus f1 y plus c minus c1 equal to 0, which is the required equation of the radical axis. Since 1 and 2 are non-concentric, g not equal to g1 and f not equal to f1. That is the main thing, right? Otherwise it will not exist. Radical axis, right? The equation of the radical axis can be written as 1 minus 2 equal to 0. Thanks.